All right, so welcome back. We're going to do some examples of, we got area of a rhombus, of a kite, and then we're going to look at a couple of examples with area of a regular polygon. So let's just get down our formulas. I know that my area for a rhombus, which is a quadrilateral with congruent sides. So in this case, number one is a rhombus. I know that that's going to be 1/2 times diagonal 1 times diagonal 2. So let's figure out what these diagonals are. It looks like half of the diagonal is 7. So we know the whole diagonal, let's call it diagonal 1, is going to be 14. And then the other diagonal here, looks like it's coming down. Half of it's 10, so the whole thing is going to be 20. So if we put these into our formula, my 20 in for diagonal 2, and 14 for my diagonal 1, we get 1/2. We get 1/2 times 14 times 20, which would equal half of 14 is 7. 7 times 20 is 140. And in this case, we are talking about inches. Area is always inches squared, or units squared. So that is my solution there. Let me just double check. 140 inches squared, perfect. All right, so let's jump back. Let's look at number 2. So same thing, the area of a kite. In this case, we know it's a kite. Not all the sides are congruent, but we have 2 pairs of consecutive congruent sides. So a kite, also 1/2 times diagonal 1 times diagonal 2. Now in this case, let's say here's diagonal 1. That's 2 plus 2, so that's going to be 4 centimeters. So diagonal 1 is 4 centimeters. And then our other diagonal is 5 and 3. So diagonal 2 is going to be 8 centimeters. So we're plugging all these things in. We get 1/2 times diameter, or diagonal 1, which is 4, times diagonal 2, which is 8. Looks like we're taking half of 32, which is 16. Now we're in centimeters squared. Let's check that one. We're good to go. So that's just the 2 examples of a diagonal. You are going to run into some stuff, though, where you might not know the diagonal. You might know this side. And so just be aware that you might have to use the Pythagorean theorem to find diagonals. So what I mean by that, let's say you didn't know that this was 2. And instead you were given information about this hypotenuse. Well, then you need to figure out that that was 2 by using a little a squared plus b squared equals c squared. So just be aware of that. It could come up. All right. So now we go into the regular polygon stuff. I created this octagon here. You can do it in your notes. It's not on there. I didn't create it. I did a snapshot of it. It'll be very helpful to break this down. So the first one just says find the measure of a central angle of a regular polygon. Remember in the notes, we start to think of, when we're talking about area of a polygon, regular polygon, we need to inscribe that polygon, meaning we're going to put it in a circle. And therefore it's going to have a center. And remember, when we need to find this area, we're going to break the polygon down into congruent triangles, into all these pieces. And remember that each segment that's from the center to a vertice, these are actually, they're all radii. And what we also talked about is this idea of there's all these congruent angles here, because they're all broken in the same thing. Well, in this case, if it's an 8-sided polygon, we know that we're breaking it into 8 triangles. See, I have 1, 2, 3, 4, 5, 6, 7, 8. So each one of these angles is the same, and they all add up to 360. So to find that, we're just going to do 360 divided by 8. Now in this case, I know 360 divided by 4 is 90, and then, well, if you type this in, I think you should get 45. So each one of these central angles is 45 degrees. Let me just make sure I'm right on that. Yeah, good to go. All right, so let's jump back to the notes. The central angle of a regular polygon are 40. How many sides does this polygon have? Well, now you have the idea of this, like, let's kind of go backwards here. So remember, we take 360, we break it up to how many sides it has. Let's use n for the variable there. And now we're getting 40. Well, what would this number be? Another way you could figure this out is to just take 360 divided by 40. That's going to get you 90. But that, or excuse me, that's going to get you 9. So you know that this is a 9-sided figure. There's 9 little triangles that break up into that polygon. So yeah, just 9 sides. Each one of those central angles is 40. That all adds up to 360. Okay. A regular pentagon has a radius of 4 inches and side length of 3 inches. What is the apothem? Okay, so let me get a little space here. I'm going to draw a pentagon the best that I can. Not great. I'm going to give that one more try, see if I can do any better than that. Apologize, my pentagon isn't great, but we're going to have to move on here. So we have some information on it. The radius, remember, if we think of this having a center and it being inscribed in a circle, the radius is 4. And then a side length, let's do that here, is 3. And I'm actually going to draw all the radiuses here. I think it's helpful. Again, I'm sorry for the picture. So we got that information. We need to find the apothem. And now remember, the apothem is the height. So it's like dropping a segment that is perpendicular to that side length. And that's our apothem. Kind of the same thing as the height of a triangle. Now, what is that? Well, if I kind of take this and look at it a little closer, I have a right triangle, and I'm going to draw it this way. I'm going to kind of flip it a little bit. I know that right here, the 4 is its hypotenuse. The apothem's that height. I'm going to write A for apothem. I don't know what that is. And then the side here ended up being just half of that side length of 3. So I know that this is going to be 1.5. And look what I have. I have a right triangle where I know 2 of the sides. I immediately need to think Pythagorean theorem. So remember, in my Pythagorean theorem, I have 2 legs and a hypotenuse. In this case, my A or my leg A, let's just have that be the apothem A. So if I'm assigning stuff, the A, that is going to be my apothem, which I don't know. B is going to be the 1.5, and my C is the hypotenuse, is 4. So I'm going to plug these all into my formula. A squared just stays that the same way, plus 1.5 squared equals 4 squared. Simplify here. I get A squared plus 2.25 equals 16. Subtract 2.25 from both sides. I'm going to get 13.75. I then need to take the square root of both sides. And we're going to round this to the nearest tenth. It doesn't specify, but that's what we're going to do. So I believe this is 3.7. Yeah, so 3.7 inches for the apothem. Okay, so I'll go back up to this space. Number 5, my apothem is 3.7 inches. Now, what's the area then? Well, remember area is this formula here. It's kind of take the area of one of the little triangles, which is 1/2 base times height, or in other words, side length times the apothem. And then we need to multiply by that by the number of triangles we have, which we just call n. So the area of this is going to be 1/2. The side length is 3. My apothem is 3.7. And the number of triangles we have is 5. And so if you plug all these into your calculator correctly, let's just make sure I can do that. You should get 27.8. And let me just make sure that I get that. Yeah, 15 times 3.7, that's 5 times the 3. Yeah. 27, you round to the nearest tenth. We're going to do that again. We're getting 27.8 inches squared. So I'm going to try to sneak this in here. It is 27.8 inches squared. All right, and next one. Find the radius of a hexagon and the length of one side. Okay, now this gets a little tougher. Unfortunately, we're going to have to use some trig. And it looks like this video is going to get broken up into 2 videos because of it. And just to review that, let's say I have a right triangle like this. This angle right here, let's just call it this Greek symbol theta. And it's just another thing we can use for a variable. But remember, just to talk about trig, hypotenuse is always the hypotenuse. But this is then going to be called the opposite side to angle theta.